Melting of ice. The freezing of water occurs at 4 degrees Celsius. When you remove the ice cubes from the refrigerator heat temperature will be less than 0 degrees Celsius. In general, the atmospheric temperature will be around 20 degrees Celsius, i.e., the temperature of the ice is less than that of the atmospheric temperature, hence now, the ice cubes receive the heat from the atmosphere rather than giving it to it. This absorption of heat results in the melting of ice. The reason due to this is that when two objects with a temperature difference come in touch with each other, heat tends to transfer from the hot object to the cooler one. This phenomenon does not need any external force in action, thus, it depicts free energy. Rolling of a ball downhill. To cause an alteration to the original state of the object, an external force should act on it. Hence, a ball at rest on a plane has to be applied a force to move it according to Newton's laws of motion. Whereas, in the case of an inclined plane, the ball rolls down without any force needed as it comes under the action of gravitational force. Here, the phenomenon does not need any external force in action, thus, it depicts the free energy. Rusting of iron. It is one of the free energy examples. The combination of oxygen and the existence of moisture is responsible for the production of rust when an object that is made of iron or an alloy of iron is exposed to it. The rusting of iron is a long-time process, i.e., it cannot be instantaneous, it needs a considerable period to achieve it. Iron rusting is nothing but the production of iron oxides due to bonding between the iron atoms constituting the object and oxygen atom present in the atmosphere. This, in turn, reduces the strength of the bond between the iron atoms in the body. Deformation. It is one of the free energy examples. An object is generally characterized by its size and shape. A change in this size and shape itself represents the strain, which is also inferred as the deformation. The reason for the deformation of an object to occur may be an alteration in temperature and also a change in the imposed force. The size of the object, the material the object is made up of, and also the force that is applied to it decide the type of deformation that the object undergoes. In general, there are two types of deformations. Namely, elastic deformation. The term elastic infers that the process is reversible. The object goes back to its original form when the imposed force is taken back, for example, a rubber band when stretched. Electricity flow under resistance. In an electric flow through a cable, resistance is nothing but the amount of opposing force that acts on the flow of electric current. The transfer of the current through wires is also influenced by the resistance. The resistance and electrons transfer is inversely proportional to each other, i.e., a low resistance allows a high electron flow, and less flow of electrons corresponds to high resistance. This phenomenon does not need any external force in action, thus, it depicts free energy. Freezing of water below its freezing point. The cold environment makes the things in that environment freeze. This is why in cooler regions, we can witness many pieces of stuff that will be frozen. As below the freezing point temperature in the environment, the tendency of the liquid to freeze in that area is greater. This is because the liquid freezes when the temperature is below the freezing point. Fireworks. The burst of brightly colored lights appears when a missile is exploded in a controlled environment. This missile is itself termed fireworks. In fireworks, we can see several number of chemical reactions taking place simultaneously in a continuous and rapid manner. Solid chemical compounds are packed and placed inside the fireworks, burning when heat is given to them. Along with oxygen, they combust and give rise to chemicals, smoke, and some gases. The released gases are carbon dioxide, carbon monoxide, and nitrogen. Burning wood. Burning wood can also be regarded as combustion. A combination of fuel, heat, and oxygen is required for the process of combustion to occur. Wood, gas, or oil can be taken as fuels. The combustion occurs due to the energy stored in the chemical bonds of a reactant.
Combining baking soda with vinegar. Chemically, baking soda is sodium carbonate, a basic compound. Whereas, vinegar is a dilute solution, and acetic acid is present in it. Thus, it represents an acid-base reaction. During this reaction between baking soda and vinegar, carbon dioxide is released, which is used for making a chemical volcano. The carbon dioxide thus released is also utilized as a chemical fire extinguisher. Magnet motor. To perform useful work, the perpetual motion of magnetic poles is harnessed, which in turn is the result of attraction and repulsion, i.e., basic properties of a magnet. Free energy magnetic motor is a device that follows this principle. Magnetism. In several devices, magnetism is regarded as a free energy source, and an Adams motor is one of them. The motor is installed with magnets which tend to get attracted to the iron cores present in the electromagnets. These power the motor by rotating the shaft. The battery is charged by utilizing the electric power that is generated into the windings of electromagnets by displacing the magnets. A normal generator is said to work on the principle of electromagnetic induction. Flywheel and magnet are two examples of free energy generators. Free energy devices. The flow of energy between the unknown sources is responsible for the production of power in the case of free energy devices. A few examples of free energy devices are hydro generator, renewable free energy water wheel, Pelton turbine generator, micro hydro power turbine, and hydro turbine. One of the excellent pros of this type of device is that there is no need for input energy. It also requires less maintenance. Frequently asked questions, facts. What are the parameters to be known while calculating free energy? To calculate the free energy, we need to know some of the thermodynamic properties. By taking the change in enthalpy of a reaction, temperature, and also by knowing the entropy, it is possible to calculate the change in Gibbs free energy. What do you mean by Gibbs free energy? The Gibbs free energy can be explained as follows. Gibbs energy, a thermodynamic property, generally denoted by Eg, is a function that was defined by Willard Gibbs, which is useful for calculating the changes that occur in entropy and enthalpy values. The produced amount of energy represents the maximum work done, which in turn is a decrease in the Gibbs free energy. What is the utility of free energy? Free energy plays a vital role in thermodynamic studies. Along with the change in enthalpy and entropy, free energy is also required to decide the viability of a reaction. Gibbs free energy is considered a more appropriate way to comment on the viability of a reaction taking enthalpy and entropy change in the frame. We can also say that the relation that is described between the change in enthalpy and entropy is nothing but a change in Gibbs free energy. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.